go the first try. Yeah. Okay. Go live. And yes, we are live. Okay. Perfect. So everybody, hi. Whoever is watching this either live or in recording, I'm assuming most of you are watching the recording. It's a good thing. Next time, join us live. You're live with Citizen Cosmos and IBC debates. Today, our topic is quality and assurance and testing. And we are right now with three guests. There is one more to join us, but I will already introduce those. And the fourth person, Jehan, if he will join us, he will, hopefully will, but we will introduce him as he will. So we have with us Viet from Celestia, Marko, the SDK lead from Informal. Sorry, the SDK lead. Sorry. There we go.
From
There we
binary
go.
builders, yeah.
From binary builders, there we go. And I'm sorry, guys. I'm sorry. I'm changing people, places, and companies. I don't think they'll be happy about it. But yeah, and we have Rano from Informal. Guys, I'm gonna take it to each one of you for a quick intro, and then we jump right into it. So, Marko, since I messed it all up, I'm gonna go to you first. What you working on, as well?
I lost you for a second, but I think you're asking what I work on. So I guess to give a short back, I came into Cosmos like 2-3 months after the Cosmos Hub launched. I was one of the members of the infamous Tendermen Inc. I went from Cosmos SDK DevRels to an engineer on Tendermen and now leading the SDK. What we do on the SDK is shifting the mentality from a maintenance project into a project where we want to push the boundaries of the technology in this space. And so we're researching and coming up with new ideas of how to best the research that's going on in this space in a more experimentation-led toolkit to build applications with. So we are teams over at Celestia and various other roll-ups also on like the research that they're doing in roll-ups. And so we're just kind of really playing around with the Cosmos SDK and trying to make it great again, I guess.
Well, great again is a good last finish there. I'm going to come back to you to that one. I'm going to come back with it. Since you said Celestia, Viet, I'm going to ask you to introduce yourself first and just quickly say what you're working on as apart from in Celestia.
Hey everyone, my name is Viet. At Celestia mainly, I'm my responsibilities are DevOps and especially testing to make sure that what we're shipping to our community is I would say pretty much reliable and safe, so they can focus on what matters most is to solve real life problems and help communities be more sovereign and enjoy decentralization. And before I will say from my best friend red pilled with what is Cosmos, and for me exposure was just ETH and nothing more. And the more I started learning about Cosmos SDK, I just understood that it is one of the shyest but the greatest tech that I'm very fortunate to be part of. So yeah, Cosmos is great. We just need to make it greater.
Dramatic, as two people finishing in the same sentence their intros. We just need to make it better. Greater. Rano, last but not least, up to you.
Yeah. So I'm from Informal. So I'm with Informal for like almost 2 years now. So I actually joined in Informal for the MBT team, which is the model-based testing team. So we were kind of building some tools for testing and stuff like to verify the spec kind of things. And so I worked for there almost like 1 year, and after that I moved to the audit team now. So now I'm working with the audit team, and maybe next quarter probably I'll move to the IPCRS team. So my main goal is to kind of to work with this kind of testing frameworks and stuff like that. So we were building this AtomCraft tool, and then so we are still kind of like trying to develop and then trying to bootstrap it. So it's happening a little bit slow right now. And to give a little bit background to my skills, so I actually did my PhD in doing testing and also in distributed systems. And after I finished my PhD, then I joined Informal. because it's about blockchains and then since I had my PhD in testing, so that's why I just kind of stayed on to doing testing. Yeah.
Nice,
Yeah.
nice. You forgot to say I stayed on to make it greater. No, I'm joking.
Yeah,
No,
and then yeah. I mean, you have some faults, so you're kind of still trying to make it better with the. I mean, so basically, what's my job is, because I don't kind of build stuff for the Cosmos in that sense, but we are kind of building the framework that will help the developers to make like really better tools, and like really correctness of the Cosmos should be the best or at the like higher level. So that's what I'm trying to do here. Yeah.
I spoke to several people from Informal over the past few years, including one particular person that fascinates me, Marko. And there are so many things that I will definitely want to get back to you with some questions on what specifically you're working on in that term. But before we get to that, I'm gonna ask like a general question, and all feel free to answer. I mean, I might pick on you if you want, but I'm gonna ask like generally, because this is gonna be first like a couple of very basic questions, and then we'll go a little bit more into it. So the first basic question, and I know it sounds probably silly a bit to you, considering you guys, the experience you guys have and what you do, but let's try to just explain it in a couple of sentences. What on earth is at all, and why should people care about it? Why should developers care about it? Why should users care about it? Why should, I don't know, anyone else care about it? If anybody wants to have a go at that.
I guess I can get started.
Go, Marko.
So when we look at QA, like the acronym stands for quality assurance, and what do we care for in the blockchain space is like that, like Rana said, that state machines are correct and deterministic. Non-determinism is kind of like the issue within blockchains, because it can technically take down in a distributed system. We come to consensus on a single state transition. And if that state transition is non-deterministic across the network, then of course the chain cannot move forward, or the database cannot be moved forward. And so in this sense, what we do for like quality assurance is really starts at when the developer submits a PR, and what it means to, and so it starts with the developer opens a PR. We do a lot of reviews on the PRs within the Cosmos SDK team. And then from there, we, inside our CI pipeline and our continuous integration pipeline, we have things like simulations, end-to-end tests, integration tests, unit tests. These are all kind of like verbiage of the normal developer, and many tools that everyone uses in Web 2, Web 3, whatever web we want to call it. And this is really important because when the application gets to the end user really cares about, and like we in the blockchain space, the UX is already not the best, and if all of a sudden we start shipping code that is also, that just gets worse, and then less users want to start using the software. And so it's really about making sure that everything works correctly, and expected state or the expected behavior is one that is written in the code, something else. Of course, like many teams do go through audits for this. We also have, we're also working on a continuous audit pipeline within the Cosmos SDK. And in this sense, like we want a third eyes on the code. So we have the developer, we have the other SDK team members and contributors in the ecosystem, but this third set of eyes is a set primarily focuses on kind of finding security vulnerabilities and also finding issues in the code. And look at the code, it's like a fresh pair of eyes coming and looking and making sure that everything is correct and that there's nothing that people can try and exploit in a different manner. If we look at a lot of these exploitations in the blockchain ecosystem, we see a lot of them are like they have usually it's like, hey, we got an audit, but we just didn't audit this piece of code that just got hacked, and like they just lost like $200 million. And that's usually like what happens, because it's kind of like the process is something that we find in the development space, because it's a space that's really in its infancy in age in terms of like new applications being built. In a sense, it's like we are trying to do decentralization, and we're trying to like move in this path of this like new world, and we're kind of forgetting that the old world things figured out. I can ramble on for a lot, but I want to leave the floor open for others as well.
Rano, Viet, do you want to add anything before I ask Marko a nasty question right into what he was explaining?
So maybe I can add one, two things. So I mean, this QA term, like, I mean, it was already there for a long time, right? But I think so it's really, really important for the Cosmos or blockchain community, because if anything goes wrong, then it's like really bad. So I mean, that's the first thing. And it's really complex system here. So it's also like really difficult to understand if your code is correct or not. So you have to be like really, really careful. The code that you're actually publishing on chain, they're like really correct. So that's why we need like really, I mean, rigorous process to make sure like, I mean, things doesn't go wrong. So it's really important for Cosmos context here.
Viet, do you want to add anything, or I can go with my devil's advocate question?
Yeah, I'll just add like the normies perspective. For example, if ever when I had first when I joined, I would say even to any blockchain topic, you have a white paper and you fall in love with it. You know that it's magical and it solves a really big problem. Then you go to the software side and you have a big question mark. How good can I trust this client? And when you add to the sauce of value added on top, like you build, let's say, the next $1 trillion app chain, you have a separate question. Not only can you trust the software, is your economic standpoint actually battle tested and proven? And quality assurance for normies is basically devs trying to assure you that everything will be fine. And please don't sit on an old versions. Like, please move forward with us. We will make sure you'll still be fine with us. So yeah, this is what quality assurance is in a nutshell.
Nice, guys. I love that. I think we can no, because a lot of people like they get scared by those words. They're like, oh my god, what is quality? Especially if they don't come from somewhat techie background. It sounds very like, oh my god, that's it. We're gonna die. Quality and assurance and testing is coming. So, so we're not gonna die. So it's all for the good of us. But here is the first devil's advocate question. Like it's a quick one, but obviously when you were guys describing what it's for, the primary cause that it's for is to make it working before it gets released. So we all know this famous quote in crypto: "Can devs do something?" Right? Like this, when moon, can devs do something? And it seems that in crypto it happens all the time. Now I'm being devil's advocate, of course, and I'm gonna partially even say my own answer, but I want you to answer. Of course, we're working with something that Marko has mentioned. It's in its infancy. But why does that happen? Even though it's its infancy, we have all those like testing teams, quality assurance teams. Why is the blockchain space known for those kind of problems more than the other spaces? Or it's not really like that and it happens everywhere and blockchains are public and that's the reason? What do you guys think is the answer to that?
The answer is basically the blockchain space is diseased with speculation. And so like if we look back at the ideology of like Web3 blockchain and why it all really got started, it was actually started for something else than what it is now. And it's like speculation has one. And when you bring speculation, like we look at like DeFi protocols that launch, no one knows who the team is, and all of a sudden they have dollars in the protocol. Like this sort of thing is like absurd. Like we've never seen such a environment in Web2 space that it's like company is and you don't know who the members of the company are, and you put so much money behind it. And not only that, it's like usually these people, first of all, the code is open source, and usually when the code is open source, you can easily like find bugs and stuff, but this isn't this isn't the reasoning, because there's a lot of code that's open source. I'd say the main difference is how you, let's say there's a bug in like, I don't know, let's say there's a bug in Postgres. It's like, okay, like you go and find who's using Postgres exploiting it. Then you have to break through firewalls, you have to do all these things. In blockchain, it's like you find a bug and you submit a transaction to a public blockchain, and you immediately can take advantage of it. And so with these protocols of this like speculation that unfortunately we've created, there's like a lot of money in these protocols, and then it's like ripe for the taking from people. I mean, it's like the biggest fear like for me is like, okay, we're getting more users. That means more people are looking at our code. So we need to be more strict on the QA and testing.
Any additions, guys? Or I mean, it was like a brief questions, but if you guys want to add to that. No. So okay, let me move on like to a proper question. Oh, sorry, Viet. I'm sorry.
No, it's fine. I was
given space. I'm sorry, man.
I was feeling that Rano wanted to say something, but yeah, I'll just step in.
I mean, maybe I will say something. So
There we go. Everybody, go. Let's go, guys.
Yes.
Let's go. I love it.
I just want to say that this, like, coming from enterprise Web2 world before switching, I just see that maybe this is a big social consensus here in blockchain industry, that we just need to prove that there is a point why you need to pursue this. And the point is that decentralization is important. And once you start to add like life to death use cases on top of it, you want to prove that it is working as expected. And because to get to that point, you need so much features, and you don't have the luxury to just move slow. You need to do fast. People just agree that, okay, we'll be the brave hearts and fail quickly as we can. The price tag is kind of like, okay, we'll just deal with this, but we just need to move faster. So literally, those users who are using right now, I have mad respect for them, because they're literally testers on manual side, and they're taking all the risk. And yeah, because I'm kind of like Degen too at night, I know that, yeah, like people voluntarily accept the risk. And this is a good signal that we need to mature better to just fix that.
Rano, you were going to add something, I remember.
So actually, I was gonna say so in the similar line actually. So I mean, the way I see blockchain has like lots of moving parts, because the whole industry is kind of still evolving. And also the other thing that I kind of feel it's a place for like money and stuff like that. So it also attracts like lots of like hackers. And the other thing is this, like, since if there's any hack, the impact is like so huge, like they make like headlines. So that's why probably you hear lots of these kind of buzzwords. Okay, like I'm just like some breach hacked and stuff like that. Maybe there's also hack maybe on Facebook and like on Instagram, on TikTok, but like people don't really care about them because they don't really kind of happening in much kind of broader scale. So that's why I guess.
Yeah, it makes sense, all of it, I think. I mean, and I think it's definitely a combination of like speculation and openness and everything else. I'm just gonna quickly introduce Jehan. Marko. Wait. What am I doing? Introducing Jehan. Send to Marko. Wait. No, just quickly introduce Jehan, Marko, and then I'll get back to you. Jehan, hi, man. We were like missed you a little bit, but hi, welcome.
Sorry.
How are you? It's all good. Just 2 words to intro. Can I get something from you, like a quick intro words? No, from you. I would like
okay. Yeah, I'm a product owner for the Cosmos Hub team at Informal Systems. Colleague of Rano's, and I've been an application developer for a long time. I've written a lot of tests, and I think what I would like to see with the type of testing that we're working on at Informal and model-based testing and stuff is in the long term, I don't want to write another test. Like that's kind of the vision for me. So never write another test. And we're certainly not there yet, but that's kind of where these tools are going to. So
yeah, I mean, that's why like Jehan is kind of depending on us, I guess, like our team's quint and stuff like that.
Nice. Marko, do you still want to add that note, or I'm letting it go, or you do?
No, I just want to say like the perfect example that shows the difference between like the Web2 space getting hacked and the Web3 space getting hacked is like Nomad. I mean, rest in peace, Nomad the bridge. But like the hack did it, and then someone posted the transaction, like how to construct the transaction on Twitter, And then everyone was doing it. Like people who don't even know how to write code were like exploiting the system. Like it's kind of like this environment of like, yes, it's decentralization. This is part of decentralization. More scrutiny than in web testing and stuff like this.
This is an interesting thought. Like, just to comment, quickly reflect on that. Like, the other day I was using Midjourney. I don't know if any of you use Midjourney, and you know, of course. And I was thinking, I can't believe that. But one thing, I can't believe that it's Midjourney, that AI, that's gonna teach people like the masses to start using basic coding commands, because to break that and like, you know, to have a little bit of like, yeah, you don't need a lot of yeah, so it's going to be interesting to see that. It's like kind of a little bit of that openness. We're entering into the Web 2 space. That's the perspective I was looking at it from. I was looking at it from a different angle. But yeah, irrelevant stuff. But let me get to the proper questions now. So the first question, and we can start with Jehan since he just joined. So I'm going to pick on him a little bit. Jehan, could you tell us a little bit about the tools that you guys use at Informal and the process, maybe? How is the testing process shaped? And maybe if you want to touch, of course, on the tools that you use personally. And yeah, a little bit on that. You're on mute.
There we go. We do still write a lot of tests by hand. So we haven't reached the goal of never running another test yet. But that's, you know, we'll do regular unit tests. We also have integration tests, which sort of, you know, are kind of written in the normal way. And but in terms of the sort of next generation model-based testing stuff that we do, I'll speak to what the hub team does. Rano's on the audit team, and they use very similar practices, but it's a little bit different in the context of audits. But on the hub team, we have we use model-based testing, and it's, or I would call it actually trace-based testing. It doesn't necessarily need to involve a model, but the way you think about that is that there's 3 parts to it. And the first part is like what I would call like a system under test infrastructure, or like a test harness. And that's something which runs the blockchain for you. So it spins up, it's a tool to spin up blockchain networks, and you know, add validators and things like that, and kind of automate the processes around that. Then there is a sort of model-based testing, like glue or framework, which gives commands to the system under test. And then there's the trace generator. And the trace generator, oh, sorry, what I should have mentioned, there's a driver. So basically the driver is a set of, first of all, like a set of actions, which execute commands on the system. So in our case, it's, you know, a blockchain, but it could, you know, for any, you could use it for any type of software, but for us, the blockchain. So it executes commands on there. And the way we do that is actually using the CLI of the blockchains, the shell commands. And that's kind of the testing library calls out to that. And then there's also part of the driver's state accessors, and those check the state of the system. So they access anything you might be interested in the internal state of the system is accessed, looked up by the state accessors. And then the third part is those two I would call the driver. Then the third part is the trace generator. And so a trace generator is basically a trace is like an execution trace is a list of actions and then outcomes. And so it's the action and then the state that the system should be in after the action. And so a trace can come from a lot of different places. And we have some tests on Interchain security where we've actually written the traces by hand. So even though it's not coming from a formal model or anything like that, it's still, I think it's still a neater way to write tests is to write the traces by hand versus like kind of the old school way of writing tests where you just kind of have a bunch of function calls and stuff. But another way of generating traces is to have a formal model. And so that's produced by languages such as like TLA+. And that's where you kind of have a definition of the whole system. And the model will go into different states, will do different things, and it will output traces as it goes through the different states the system can be in. So it'll say, and it can do, you know, thousands and millions of different sequences of actions in the system. And so then you can play those back, and those get played back into the driver, which executes those actions. And after each action, it checks the state. And so that's kind of, that's kind of the basic setup for model-based testing. And I could go more deeply into like the types of the model that we use for interchain security. But like I said, we have some tests which run from a model, and we have other tests which are more around the peripheral functionality, where we actually wrote the traces ourselves, because it would have been like too much work at this point to put all the random stuff like making governance proposals and stuff into a model. So yeah.
How many like rounds of testing for it? You said, you know, we have for each function there are different tests. How many times would each function get tested until you are safe enough to say, hey, this is working, let's go?
Well, each individual function is being tested, you know, millions of times.
Millions of times.
Given that the tests run all the time. So, but I would say in terms of the number of tests for a specific function, well, we still have regular unit tests where the person who writes the function will have like a few sort of scenarios off the top of their head, which kind of illustrate how it's supposed to work. And that's, you know, very traditional type of testing in software development. But then in terms of the model-based testing, our model outputs thousands of traces. And so each of those traces can then, you know, it will call a bunch of different functions, because each trace is simulating a different scenario. So that's really the power of model-based testing to me, is that you can have, like, you can write once how you think the system's supposed to work, and then from that it can output a basically unlimited number of tests. And it's not guaranteed to be correct, right? Your model has to be good too. If there's something you forgot in your model, it's not going to be tested. But the stuff that you are covering, it can be tested in like every kind of permutation possible.
Okay, thank you. Rana, I'm going to move on to you, since it's interesting to hear a similar, I guess, somewhat description, since you guys work almost together, but with the same project, but different teams. And it would be very interesting as well from your perspective, as somebody working on a parallel team to Jehan, explain how is your testing helping his testing.
Yeah, I mean, so it's basically the same setup here, but so for Jehan's team, so they have their own, like, so I think it's like a TypeScript model, but here, I mean, for us, so we actually use the TLA plus models to kind of generate the trace, and then we do the same thing on the on a blockchain that we're auditing. I mean, it's kind of like a similar setup, but we actually do it for audits. But yeah, so we also kind of write the so we say spec, so it is kind of like a and then for that we use the TLA plus languages, and then you write them in a spec, and then you use this tool called Appalachian, and then you generate these traces, and then you can run them back on the blockchain using Atomcraft or stuff like that. Yeah, but so one thing that I want to mention is that this is like the most highest level of testing. So at the beginning, you have to start with the unit testing, then the integration testing, then the end-to-end test, stuff like that. And like, so at each stage, so you kind of eliminate some very like silly mistakes and stuff like that. And at the end, so you do this kind of model-based testing. So it's kind of like a bit of, I mean, layered approach of doing QA. So yeah.
Okay, thank you. I'm gonna leave Viet. I'm gonna leave you for last, because the Celestia testing is. I'm gonna leave you for last. Marko, can you explain next what is your process in binary holdings and in testing, and tools you use? Is it different from what Jehan and Rano are describing? Do you guys have a different approach to that, or is it the same?
I think we do like a fairly similar approach. We don't use we don't have any like formal verification methods or something like that. But we kind of have like unit tests. We just write normal Go mock tests, and then we have integration end-to-end tests. And then we have the simulator, and that's kind of like where most things come from. Of course, like right now we're in the midst of like three different work scopes, not all working at the same time. The first one is we're defining a canonical integration testing framework between modules. So the core idea is like treat a module. Well, I'm not going to go into it because I feel like we might lose some listeners. But then we're working on an end-to-end testing, canonical testing framework. This could be like in conjunction with interchain test and in-process design. And then the simulator is kind of right now a fuzz tool. So it will find, either where your application is non-deterministic or where your application can cause panics, which could end up in chain halts. And there, the work scope for the simulator is actually to refactor the simulator to be more intelligent, so we can do more things there. On top of, we're collaborating with the Informal team to potentially like integrate like Quint. Quint is like an alternative to TLA Plus that they've been developing, and it generates a like JSON output, and then we're thinking of like how to incorporate that JSON output into the simulator to be used as a like seed of sort for the simulations. So this is kind of like the approach we're taking. On top of that, like we do a lot of manual things. So we set up like for this recent release, for the Twilight release that just got released actually, as we were on this call, we ran a testnet with IBC and cosmwasm. We opened it up to the public for anyone to really play around with it. And Wasm ran their test, IBC ran some tests as well. And then we do like a manual QA process that everyone gets assigned. So you basically, we have a bunch of code that everyone touched. And basically you couldn't have been a reviewer and you couldn't have been the author of that code. And now you need to go and audit that code. And so this is kind of like the process we are following right now, but we're working on integrating a more third-party audit process. We're working with the team at Informal as well here, and with other teams as well.
Sorry, I forgot to unmute. Just a quick question before that, a moment of advertisement. If you guys want to listen to more about Quint, we had Marko from Informal present Quint. It was a couple of months ago. It came, so go to citizencosmos.space. And he talks quite a bit about TLA, about Apache, about Quint, and about formal verifications, and so on and so forth. So if you're interested more about that, have a listen. Marko, before I move to Viet, you mentioned audits. Do you think that it's appropriate or not appropriate, or if you think it is, will we see in the future more, since we're talking blockchains and decentralization, teams' involvement more of the public in testing, especially when it comes to stuff like contract testing and things like that? I mean, I think I'm going to say that because I think I've seen something similar in one of Ethereum project. And basically what they were doing, they were kind of having like a reputation system for testing certain contracts or whatever from just the general public. And the more reputation it got, the more closer it was getting to release. I don't know whether this thing lived or not, and I don't know how they do it now. This was like a year or something ago that I saw this. But is anything like that for audits make sense? Or is that a pile of bollocks and we need people who know what they're doing to test things?
That's an interesting use case, and I've heard of very similar things. I think I have the same team that you're thinking of in mind. I just can't remember the name, or if they're even still alive. But I think that like why in the end, it's like, why do you end up working with auditors? Is like either you're paying them because they know they have expertise, or and that's basically it. And it's like if you leave it to the general public, it's like you pay an auditor $50,000 and you're like, oh, I can do it cheaper if I go to the general public and go and try and get away with $20,000. Like you're going to get some, but you're not going to get like a well thought out like review of the code that is being touched. And so that's why it's like going to an auditor. I mean, like this is the part of like decentralization that like there are some interesting teams like working and thinking through different approaches for decentralization of audits and creating like a marketplace. There's always been this idea of like auditors kind of putting up a stake to audit some code. So like if after a year the program doesn't get hacked or something, they get some funds, they get their funds back and stuff like that. There's a lot of different designs, but I think it's like leaving it up to the public is like this kind of goes into the realm of like incentivized testnets, which I'm not a really big fan of, to be honest. Like I don't think they actually provide the biggest benefit that teams are looking for, because it's like, well, for one, it's like you have to incentivize it, you have to add something on top, and then it's like, okay, like if we took that money and did an audit of everything, and then we ran like an internal testnet of like an internal hackathon of like a chaos hackathon on this code, would we provide better results than an incentivized testnet? I think that is the way that it would be, or like asking friends and stuff. But I think like generalized incentivized testnets in most scenarios are pretty pointless. I think in the scenario, like two teams in my head, like Celestia and Say, are like two use cases of incentivized testnets that make sense. Of course, as an incentivization model, I still have like a bit of apprehension with, but I think they make sense because they're trying to test a technology that is like new and not thought out, but like they're testing network configuration. Say is testing like speed and performance and all these things, and teaching their validators on how to run in the network, because it's a lot more complex than just spinning up a node and just running with it. And so it's like those sorts of things make sense. But it's like if you're doing an incentivized testnet for I'm not going to mention names, but like if you do incentivized testnet for like a module or something, then it's kind of like, okay, like most of this testing we could have done on our own.
Okay.
Okay.
So
go
on, Jehan. Go on.
I don't want to take too much time because we still got to do Viet, but I had some. I worked on Gravity Bridge and the Ethereum contract for other things as well. But we got a crowd audit for the Ethereum contract from Code Arena. This is a few years ago now, but they did a pretty thorough job. I mean, nobody in the crowd audit found an actual vulnerability, but we still actually awarded some prizes because it was like people really got deep into it. And I think what was missing was like a holistic sort of like understanding and view of the entire system. But from that experience, at least, we did get a lot of people scrutinizing like every single line, which was cool. So I think if there had been some kind of a typo-based vulnerability in there, that crowd audit, could have found it. But I don't know if they would have found, more of a nuanced, subtle theoretical vulnerability,
It's an interesting topic because what incentivized testnets have become as well, they become a little bit political as well, right? Like for validators, and if a validator participates, doesn't participate, how he participated, what he did, what he tested, and then like, yeah, but let's talk about it in a second. Viet, sorry to leave you for the last, but the reason I'm doing it is because, of course, well, you're probably going to explain yourself, but Celestia, right? It's a bit of a big thing in terms of kind of like what you guys do, and it's not concentrated on one particular ecosystem, right? The concentration is like on a lot more. So I'm assuming, and again, this is an assumption I'm making, and here, please correct me, that the testing you guys should be doing or doing is probably much more. But please correct me if I'm completely wrong on this, and please talk about the way you guys approach QA and testing.
Yeah, I don't want to eat a lot of time. So at Celestia, we also do unit and integration testing, as most some team at Cosmwasm. Still, as you hear from all three, and yeah, 4 of us here, including me, I forgot to call it myself, is there is a lot of innovation happening on system level tests, especially when we talk about, hey, let's deploy 100 validator set and see how it behaves. And let's trick around, see that it is safe to use, because there was lessons learned in our community with 0.35 when literally it was just, I would say, cowboy release, and everyone got hurt along the ways. And lessons learned now, we're just getting back to the roots, making it safer. And at Celestia, this is one of the moments when I would say the leadership team basically asked the simple question: how can we make sure that the mathematical proofs, theories that we have there, how can we prove that it is actually true in real life? How can we replicate a model? And because Celestia has a lot of node types, how can we prove that it's correct? And for me, I don't know why, but immediately I got an analogy that, okay, if we want to test an implementation of a white paper, then a white paper, it looks like a script. And you as a tester become kind of like a director of a movie, and you need to set up a stage in a way where there's a lot of crowd and they're doing a specific role, but there is a main actor and there is a protagonist. And you need to make sure that both of them are playing by the screenplay. So the only solution we found when it came to system level testing, especially on a large scale of nodes talking to each other, is to use test ground, because we had this, I would say, unique challenge that we need fine-tune control of each node type. what it is doing. And we don't want, as I totally agree with you, Jehan here, writing a bunch of tests makes no sense. We want it to be very efficient in how we can write once and then replicate on the large, I would say, a very flexible style. Like you start, for example, with 20 validators, let's say 100 light nodes, and then you see how. And then you basically say, okay, now we replicate mainnet. We have a full validator set. We have, let's say, 1,100 light nodes, and they're submitting data. Their availability sampling kicks in. What happens to the network? And test ground basically help us to even test, I would say, the worst case scenarios. By worst case scenarios, I mean testing the honest minority assumptions. And in Celestia, one of the minority assumptions is block reconstruction. When a full node cannot get all the data from other full nodes, it's basically DDoS or whatever. And the only way it can get all the data back to reconstruct the block is through talking to all the light nodes that it is available in the world. And there is a mathematical, I would say, formula how you can get that. And testing that was one of the biggest, I would say, challenges I had. And it just opened my eye how testing can be done. And it is awesome that there are different, I would say, paths to just come to, the same outcome, which is safer blockchains. But yeah, for us, we just picked test ground because it solved a specific use case for us.
Can you talk a little bit more about that? I mean, you said this opened your eyes to testing. Come on, let's talk details. We can be technical.
Yeah.
Don't worry about it. Like go.
Okay. Go more about technical. I would say, when you do large scale network tests, there is a specific, I would say, elephant in the room. Everyone is kind of, I would say, aware of, but nobody knows how to deal with it correctly. I would say in a standardized way is, if we deploy a node, how we make sure that it has enough resources to accommodate the load it will produce or consume. And when you talk about, for example, spinning up 1,412 light nodes, you need to know that they have specific resources that they can accommodate and they can share back to a full node. And imagine one full node talking to 1,412 light nodes, like how much resources it should have. And we should, because in testing, you also have assumptions that, for example, hardware specs are correct. And you say a full node has, I don't know, 40 cores and 256 gigabytes of RAM. Is it enough? And when you introduce latency and network, okay, is it enough or not? And yeah, you just.
I'm just commenting that it's a fucking big ass node. That's it. But
Yes.
sorry.
I mean, it's just an interesting point of view from one test case. How much variables there are, and how you want to, how much you want to assume. So, for example, you assume that hardware is not an issue. You just increase it to a very big one. But then you go to more real life scenario and say, okay, a full node might be run on just a Ryzen 7, which just has 16 threads, and the best case scenario, 64 gigabytes of RAM, and that has a 256 fiber. In this worst scenario, when he cannot or they cannot talk to any full node, can this case work in real life? Because because we understand that people who run full nodes altruistically or not, they will not do it on on AWS grade machines or racks. They just do it as a hobby. Or for example, a light node. There are a lot of people who are running light nodes for Celestia on Raspberry Pis, and it brought to my eyes a interesting case that, can you actually run a light node with half a thread and 1/3 of a gigabyte of RAM when the system is producing big blocks, when it's just full constant big blocks, it's pumping up of every 15 seconds. Can we still prove to the community that they don't need a lot of hardware to do this? And the more you have light nodes, the better the security of the whole network is, because everyone is sampling basically. And yeah, this was an interesting question for us, and we were very happy when we just proved works fine. And it was, yeah. And in test ground, for us, it was literally a change of code. I mean, not in code, but in config. Like instead of running 100 light nodes, we just increased to 1,000. Like it was a one-liner change. And because we can configure each light node, how much resources it has, it was also kind of like, yeah, one-liner change. And we just deployed it, and we're watching a movie.
Jehan,
it's funny. We actually have the luxury of not worrying as much about the real network. And I think, Marko's team probably to some extent too, because we run in the state machine, in the Cosmos SDK state machine, and we're taking for granted that Tendermen works. So it's like, also hearing you talk about testing Celestia reminded me, I was talking yesterday with Thane from the, Comment, I guess it's, called, from the Comment team about testing that. And it is it's a whole nother challenge, testing something where you need to test the properties of the P2P network as well. So for the Cosmos Hub, we can just test that there's no sequence of transactions that results in money being stolen or whatever, or DOS or something. We don't necessarily have to test that those transactions can be gossiped within a certain speed and made available and stuff like that. So yeah, that was like I was thinking about. We're actually working on even abstracting out Tendermen or Comet from our testing setup completely, and using something called Tendermock, which is kind of still under development, but it will allow the Cosmos SDK like state machine to talk to something it thinks is Tendermen, but responds instantly and has no latency, and you can control time, control blocks, and all that. But that's not an option if you're actually working at the lowest level like you are.
I just remembered an awesome use case that happened to us in January. Thane, if you're watching this, hey, we had the call with Thane, and he was basically telling a story that they're trying to do bandwidth tests when the Tendermen nodes talk to each other, and we basically got into the same bottleneck that the mempool was just too big, and we could not accommodate we had a task to reduce the amount that the mempool in bytes has. And one of the G's in the space, Callum, if you're watching here also, shout out. He got an idea how to implement that. And it was an eye-opener, I would say, also for us here when in test ground, we just changed one line in GoMod and we run the test and we immediately saw like 16-fold reduce in bandwidth, and it was measurable. Like you can literally replay with existing stack and then with the stack that Callum did, and we were just redoing it to just prove that we are actually right. And now it's in the device testnet release. So I was just so happy that when it was done, and yeah, I believe that we should just improve on something like this. Like and testing should be very easy for people and not that cumbersome that it is right now.
Talking about easiness and about what Jehan said and about assumptions and Tendermen, this brings up a question to mind, kind of obvious, but can you ever get to a point where you test something without assumptions? Because you're going to be relying on something, right? Whether it's hardware or software or a person that's testing. I don't know. There's always assumptions. No bandwidth even, for example, I mean, could not go through, right? Is it possible not to rely on any assumptions in testing?
It really depends on like really how you're like, if you're not relying on assumptions, then you're kind of like, what are you testing?
Yeah. That's what springs to mind. Yeah, I'm just curious about like what Jehan said, and it made me think. But yeah, I mean, we all rely on Tendermen, right? And it's like,
I think part of what you're doing in your testing is you have like two implementations. You have the real implementation you made, which is going to be in production or is in production, and then you have your test, and they both need to line up. And so if you screw up your implementation, the test will break because it's no longer doing the same thing as whatever your testing abstraction is. And so with a traditional type of unit test, that might be just the sequence of steps you typed in yourself, which you think should result in a certain thing happening. With a model-based test, that's the model. And then also even with fuzz testing, like the SIM app in the SDK, there's also kind of a model there, and that's just that you're putting transactions in. That's actually interesting because you're actually using panics in the implementation itself, but you're in every case you're trying to make sure it works in a certain way. You need to specify. You need to have a way of specifying what the way is that it's supposed to work. And so if you don't know how it's supposed to work, then you can't test it because you have no basis to test it.
Exactly, and I think it's like if you're building a modular, shout out to Celestia, modular framework or like composable framework, then it's like there's still like a set of default assumptions that you are making for the application you are providing, but you're saying to application developers, hey, like if you don't like these assumptions, you can modify them, but like they are like if you change out, let's say in the SDK, like in the next release, like the store package will be like replaceable, and so you'll be able to replace the store package. There's going to be like these assumptions that we made on these like interfaces and like kind of like how these lower levels kind of work. But it's like if you don't abide by those, then it's like you're kind of outside our security scope because we can't provide security based on code that like isn't within the SDK or we know or something like that. And so it kind of like increases. It's like we can only provide like tests and safe assumptions and like sane code on the code that we know.
This is also a good point because again, we're talking about like a decentralized space, right? Ideally, do people, I mean, in your experience, when you do those assumptions, and hypothesis assumptions, right? Theories, whatever, do the validators to participate or any other people that participate in the incentivized testnets, or do they do and change those assumptions? Do they offer propose new things to test, or is it usually just what the testing guys, yourselves, or I don't know, whoever, how to call it in one word, sorry, wrote originally and then put out here's our assumptions, this is what we're testing, and that's how it's going to work, and then everybody comes tests. Go on.
Yeah, I just want to quickly say that everyone learns it the hard way, like sooner or later. When you start to talk about testing with no assumptions, it literally falls down into the category of the rule everyone learns is exhaustive testing is impossible. And this is where everyone hits the rock bottom when they understand that, okay, we cannot just assume everything and everything is just the Wild West. Like the goal of testing, again, is to assure the quality. It's not to say that this is the safest world, the safest place in the world. We are, I mean, it is really important in testing to know exactly what is the roadmap of the product you're going through. And you need to make sure that there is at least some amount of coverage is done. Like we all know that the space here is still small dev-wise. Like we have 20 million of devs, and I highly doubt there is at least 1 mil in the whole industry. And I don't think that the majority there it sits in Cosmos. And in testing, we're counting fractions. So people get really efficient in what they really want to test. And hence why assumptions, they are also configurable. Like they're not saying that, okay, we will always assume that 2/3 is working on Tendermen. No, it's not. Like I'm 100% sure there's someone who is asking the same questions like, okay, we need to test BFT actually, like, or we need to go to the consensus reactor or to the mempool. Like this is what basically Celestia did. We just asked the question, maybe the mempool, we can make something out of it. And yeah, I think we're doing fine. It just means that we want more, which is what, again, Marko said, we'll need to make Cosmos great.
But by the way, but this is like the in my experience, and I haven't launched that many products as probably you guys have, but I have launched some, including decentralized products. And my like biggest lesson, because I'm not a tester, I mean, you should not use my scripts unless you want to break something. But anyways, like what I learned is that you will not have, doesn't matter what assumptions you're thinking about, you'll never think about that user who came and pressed that button. And there will always be that user and coming and pressing that button. And in blockchains, it's a lot to do with economics as well. And usually, like the economics are left completely, usually a bit untested in my opinion. But then again, what I'm trying to say, I see Marko is reacting good. I was trying to get that. So what I'm trying to get at, and I want to hear what Marko, maybe you can retort to that. not in terms of like, no, we're not testing, I don't know, the module, the banking module or whatever, or we're not testing how transactions go from point A from point B, how staking. What I'm talking about is, and I know that we are, but sometimes we test complex mathematical models instead of testing something very simple. And then usually like all those hacks, especially on Ethereum, they do happen usually because of a very simple thing that somebody, I don't know, input a number somewhere, or he did something economically which wasn't like, you know, checked originally, and then that break happened. So are testing economics a lot. Why do these hacks then happen with simple mistakes?
I mean, I think added on to like, so first of all, like this is kind of like one of the biggest like reason why I love this space. It's like it's on the cusp of like technology and economics, where it's like if you can't solve a problem in a technological way, you can sprinkle some economics on top and solve it in a different way. And that's like the most interesting thing, because it's like two things that really like people that really like make you think and really guess, and like not guess, but like really think and like research on possible ways. And there's been like hundreds of different like economic designs, and it all comes down to human psychology and like how hard, in some cases, how hard you can meme it, like with the 3-3 ohm stuff. But like I think that in the scenario, it's like it's very hard to, because like in the economic approach, you're kind of like, to test it, you're testing like human psychology. It's like you're not testing really like, oh, like this state machine, if I give it this function, it will go from A to B. It's like you're giving a state machine A, and it can go through any alphabet any letter in the alphabet, and it just kind of like you can make a guesstimation, and it's like this is why it's like usually it's like, oh, like this is how we made an assumption, and this is how it's potentially going to work. But then like in a bull market, it's like it could be like doing really well. In a bear market, it's like changing. You need to change your entire like construction of economics, and so it's like it's kind of like you're throwing like at a certain point, probably a monkey throwing darts at a dartboard, choosing your economics for you is probably going to be more efficient than doing all these mathematical models. But I mean, this is also goes back into that one experiment that they had monkeys pick stocks and traders pick stocks, and the monkeys won. And so it's kind of like we can at the end of the day, it's kind of like this space was built on experimentation, and that was the ideology. It's like, okay, it's like providing a currency that is like not controlled, but also providing experimentation on like what is possible. And I think it's like some teams still do that, but a lot of teams just go with the norm because they know it's what people know, and it's just kind of like creating a paradigm shift. It's like this kind of like what I mentioned earlier, this like disease of speculation within the Web3 space is kind of like what's leading to these like simple economic models that it like doesn't expand out into more experimentation, because they need people to come and buy the token to number go up and stuff like that.
Yeah, it's interesting. Yeah, does anybody else want to add to this? Because I have comments, but I want you guys to add, not myself. Rano, maybe you do you have any thoughts on testing on this?
So one thing that I wanted to say is that regards in the sense that why sometimes some very silly mistake get passed by, and why it doesn't get catched by this kind of safety net. I mean, so the thing that I believe that easy to make mistake, but it's very hard to find that mistake. And as I said before, it's kind of like a layered approach. So you probably you can never reach that kind of 100% correctness, but you can kind of go like 99 or something like that. I mean, to test everything, like all possible behavior, like it's really difficult. But we can try to mimic that kind of behavior. Like, I mean, that's what we're trying to do with Print and then Atomcraft, with this kind of bit clever way of kind of simulating this behavior, things like that. So yeah, I mean, I guess sometimes some things get missed, like get kind of missed, but we can only provide this kind of very high guarantees, or like high, high confidence of the correctness. So yeah.
Let me guys ask you one by one. Jehan, before you joined, the guys unintentionally all proposed to make Cosmos great again in their intros. But keeping that kind of sentence in mind, And I don't know if this is going to be the resume question or not, but whatever, this is up to you guys. But it's probably going to take a little bit of time for each one of you to answer for sure. Like, if we were to stick to that sentence, make SDK great again, make Cosmos great again, and what else did we say? Make everything great again. Considering, like, taking into assumption, let's do some testing here, some assumptions that Cosmos is something that's going to grow, and for many years, I personally have predicted that we will see a lot more Wild West chains and Cosmos than on Ethereum has ever seen, like with the way that it's going, and it's good. It's going to be used more, right? And we're seeing already some things break here and there, but in some certain chains, that are probably the testing properly. So here's the question. In order to make Cosmos great again, and for everybody else, considering you guys like that really amazing experience in testing side of Cosmos, to advise to those teams that are building something right now, planning to build something on Cosmos in terms of like testing and Q&A, do what or don't do what, and anything like that. Maybe we can start with, again, Jehan, maybe you again. We're gonna go like
Yeah, I think my advice would be that, in terms of testing, I think my advice would be that really the only, regardless of everything we said about testing, the closer you are to it actually running in production, the more of a real test it is. And so I think that my advice would be, look at it as, you want to try to do is, first of all, cover as many scenarios as you can in your integration tests, and then have your unit tests kind of just be an early warning system, because integration tests often take a long time to run. We're trying to speed it up a lot, and they're also hard to debug though, because when something goes wrong, you have to debug it in integration test versus a unit test tells you exactly where it was. So I would say, look at your integration tests as the main source of truth, and your unit test just as an early warning system. Because ultimately that's what matters, is that your thing runs correctly, not that the tests pass. So.
Sorry, I the unmute button. Thanks, Jan. Marko? What would be your suggestion? If you can hear me, Mark. There we go.
Yeah, sorry.
Okay. Same, unmute button is a terrible thing.
Could you repeat the question just so I can?
Yeah, I'm gonna make
recall?
it shorter, of course. For us to make Cosmos great again and everything else again, what suggestion to the teams that are building currently or planning to build on Cosmos? What exactly to, and which unit tests, or which I don't know, anything else?
I would say like the most important thing, and like the thing that a lot of chains that end up suffering issues don't write is the simulations. They're a bit cumbersome to write. There's a lot of boilerplate included. This is something we want to fix, but this is like something that will help you find issues that your tests won't find right now. It's very easy. The tests are randomized. It's a fuzzer. All you need to write is like some weighted operation functions, and then from there everything else is handled for you. And this really like helps you clean up your code and find stuff that you may have not known to be an issue. On top of that, for like teams coming to Cosmos, I'd say like let's start thinking outside the box a bit, like in terms of like new teams coming and like new teams wanting to build. Like there's a whole plethora, there's a whole world out there of things to build, and right now I think a large part of the blockchain space is just caught in this like circle of like the same thing over and over and over.
Okay, thank you. Rano, what about you?
Yeah.
Guys.
So so my background is in the correctness, so I will kind of talk about that. So the first thing is that you should always write test. Like, I mean, if I see a project which doesn't have any test, I'm like, okay, I mean, something is wrong with this project. Okay. So what you can try to do is that, so start with unit test, then you kind of go up in the level. So I mean, you have the unit test, so then kind of try to write these tests for the integration, and then you go to end-to-end test, things like that. So always kind of write test for the code that you have written. So if you have some peers, always write test for it. So that's the number one, if you're a developer. And the other thing is that when you have some idea about some module and stuff like that, always can write down the idea of it. So we use this kind of the tools like Material Plus or Quinn, things like that. So something what happens, you don't even have to test it and you find bugs. So when you kind of try to write stuff on paper or stuff like that, you can see sometimes a bug in there that you didn't kind of think about before. So it's kind of like the point of writing stuff in somewhat like a math. It's fine if you just do it something like a diagram on your paper, Excel draw stuff like that. That really help to kind of find or to remove some of these kind of silly mistakes that you can have. So yeah, just kind of 2 points from me.
Thank you. Viet, again, last but not least, and I don't know if modular advice is going to be to test different, but let's hear it.
I would say the easiest TLDR advice is regard testing to brushing your teeth daily. It's always a little bit, I would say, it's always a little bit buggy, especially when you have a big hangover. But remember that in the long term, if you don't do it every day, maybe there'll be a lot of bills to pay to fix that up. And second one, I would say that I think, yeah, be aware of the new tech, who is doing what on testing side. For example, go to Awesome Cosmos testing. You'll immediately see the G's shipping like there is no tomorrow. And I think a good thing will be to grow our community to a sense that we'll have something like car manufacturers did with standardizing Euro NCAP or NHSA, when you basically crash test the blockchain to see that it works fine on a specific standardized metrics. And this will be the golden future. Yep.
Nice. I don't know if formal verifications, what Informal is working on, will allow you for that, will it?
It has to be both, and that's the bridge that you're trying to build with Atomcraft. So we have the Quint and Tele Plus, which is totally formal verification. And in that, you can actually kind of formally verify the specification, but since it's not about the code, so that's why I didn't say about it. Okay. So the thing that you can do, so you write down stuff in Tele Plus, then you can actually verify, and then you can actually use those tools to kind of generate these traces which you can run on. So it's kind of mix up both worlds that we need. Yeah.
Okay. Yeah, Jehan, go on.
Oh, I was also going to say, just in terms of model-based testing, it's something that's, it's been around for a long time, but it's kind of cutting edge. But also, I would say that fuzzing, like with the Sim app, is a form of model-based testing. So I think the important thing is that the next level of testing is when you're not just doing individual scenarios, which you kind of have to write out by hand, but where you've modularized your testing setup to where you have something that you can run an arbitrary sequence of commands into. And so fuzzing is actually that. So I would say, I think, Atomcraft is still pretty early, so we don't have a complete package for people to use yet, but we'll be working on that. But you can also do it yourself. Even in your tests as you're writing them, there are a lot of gains to be had just from kind of modularizing it and making it easy for yourself to sort of write tests with less boilerplate in each individual test.
Nice. Guys, I'm gonna give one piece of advice to resume myself as well, which actually none of you said, so I don't know if you're gonna throw stones in me or not, but in my opinion, if you're building in this space, open source your code from the beginning and then build. And already we've seen example of teams that don't do that and break. I'm not gonna mention anyone. But in my opinion, well, there isn't. Yeah, I'm sorry, it's not that hard to guess. But hi. So yeah, in my opinion, that is one thing. I don't know if you guys agree with it or not, but yeah. Guys, any sort of last comments on Q&A and testing that any of you want to give, or have we kind of touched on the tip of the iceberg a little bit, and it's a little bit more clear what your job is and why it's for? That was the goal, I think.
I will say that if you're looking at a function and you're saying to yourself, I really don't want to test this or write the tests for it, there's most likely a bug in it.
Okay, I love it. I love it. I love it. Okay. Guys, with that sentence, I think that should have been the sentence of the sentence of the program. Damn it, I'm losing words already. That's it. That should be tested before that. Guys, Jehan, Rana, Viet, Marko, thank you very much. Thank you very much for finding the time, getting out of the testing and fighting infrastructure, and coming to the Web2 world to say hello and to explain what you guys do. This is very important in my opinion. And thank you guys for all the things that you do. This is important for all of us. So thanks. I'm just gonna stop the stream. Please don't hang out. Don't hang up yet, guys. Just say bye to everybody who's watching it. Bye.
Bye. Thanks for having us.
Bye bye.
Thanks for having us.
So.